We are now doing lesson 75, which is counting by weighing. So, what does it mean to do counting by weighing? Well, when we have a huge number of things, like atoms or molecules, the easiest way to count a large number of tiny objects is to find their total mass and divide by the mass of one of those objects. Right? So if I have like a bazillion beans and I want to know exactly how many, that's a terrible example. Say I have a huge number of beans and I want to know how many it is, like tens of thousands. Well, I measure the entire amount of beans and I divide that by the mass of one bean. So you can do this math, whereas number equals, that's how many you have, total mass, which is what you got, times that conversion factor, that ratio of one object, and this is the average mass. So this would look at, like, say back to the beans, this could look like something like one bean is 0.03 grams. And you plug that in here, and let's say I had 30 grams of beans. Well, I know if I can cross out the grams now, and I would say 30 divided by 0.03 is equal to, let's see, what is that? Yeah, 1,000 beans. Okay. Now, you still might have to do some counting in order to get the average mass of very small objects. It is better to find 10 or 20 of the objects. Better to mass 10 or 20 and find the average that way. Right? So, especially if the objects are about the same size. So again, for beans, like, it's hard to put one bean on the balance and find out what the mass is, because the mass is so small and our balances are not nearly sensitive enough to be able to pick that up. But if you may measure 10 or 20 beans, then that mass might be enough to be measured on the balance. And if you do that 2 or 3 times with 10 or 20 different samples, you could get a very solid average. Well, how does this relate to chemistry? Well, you know this. I've said it over and over and over again. Atoms are very, 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 times a lot, small. We can't count them individually. So because we can't count them individually, chemists use mass. I'll put we because we're all chemists, use mass when measuring chemical compounds. We have to use mass because we can't count. So remember back when we were talking about gas laws, we introduced this idea of moles. So number of moles of a substance is equal to the total mass divided by the average, what we're going to call the average atomic mass. And we'll talk more about this in subsequent lessons. This is something we're going to get familiar with. All right, percent error. Used to express how close scientists are to an actual value. So we use this in labs, right? What is your percent error? So we have maybe a known amount, and we're trying to measure in the lab. So we do this thing called percent error, blue percent error equals the absolute value of the observed / measured minus the actual, that's it, over the actual times 100%. We do the absolute value because we don't want negative percent errors. It just allows us, it's just relatively how far off are we from the expected value. Okay, wrap up. How can math help you count large numbers of small objects? We can count large numbers by weighing them together and dividing by the mass of a single object. It's more accurate to weigh a large sample and find their average mass than to rely on weighing a single object. And this is especially true if the objects are slightly different. And there are so many atoms in a sample that you cannot count them. So we use mass as a way to actually calculate the number of atoms.